Hello and welcome back to the Linux Panic YouTube channel. This is video 6 of my Linux from scratch version 11.3 SystemD edition. Where we had previously left off, we had just finished with the cleaning up of the system in chapter 8.080, where we just finished cleaning up. We've got rid of the test user and we are now ready to move on. As we can see here, we've done all this. Everything's been sorted out. Yes, I had to remount the system mainly because I had accidentally I accidentally turned off the virtual machine instead of saving it, meaning I had to remount my system. So that's why it's not showing it, but the tester user was removed. Now we need to come to the system configuration section. So this is just preparing the system configuration ready for actually starting the operating system. So first things first, the introduction, it just explains what these do. Chapters 9.2 discusses files and devices. 9.3 and 4, second issues that affect proper start with devices are discussed. System clock and keyboard. 4 being brief introduction to scripts and configurations, as well as logs, and there preparing and finally configuring behavior SystemD is discussed. So, first things first, network interface configurations. What this here is just saying if you will not use the SystemD networked for configuration, or for network configuration, execute this command. So, for example, if you're going to use Network Manager, remove this, and then it will disable a service to prevent an error message in boot. Network device naming. UDEV normally assigns devices based off their physical characteristics. So as such, and if you're not sure what your interface name is, you can always run IP link. So that just shows them all the link interfaces. Most systems, there is only one network interface of each type. For example, classic interface would be for wired would be ETH0. That's most likely what you've got, or ENPS1 something or other. If you prefer to use the classic customized network interfaces, 3 alternative ways to do that is mask udevs.link file for the network policy, create a manual naming scheme, something like Internet 0, DMZ, LAN 0, and such, or see main page or in grub or boot/grub/grub.cfg, pass the option net.iframes if names equals 0 on the kernel command line. So because I don't want to be doing any of this, we're just going to leave it be. So if you prefer to use the classic customized, we're going to go with the classic. So that's what we'll move forward with. So if you prefer to use customized, 3 alternative ways, because it's 3 options, we're going to use the first one. So first things first, we're going to CD back down, so we will be in the home. Past that. Next thing we want to look at is the IP configuration. So in this case, the command line below creates either a static IP option or a DHCP configuration. Now, in my case, I'm quite happy to just move forward with DHCP. So, for example, multiple DNS entries can be added if we were doing this. So if we do IP link, what we can see here is ENP1S0. And what we can do is we can create either a static or DHCP. In my case, we will run a static or a DHCP. I will get there eventually. I very much had to engage the brain. So this will be ENP1S0, as that is as it states here. Enter network device name. In this case, it is ENP1S0. The resolve file is kind of important because it gives you this here. This can be a bit confusing because it's domain and all this. It's no need to worry because this requires a fully qualified domain name later on. But first things first, if a static resolve file is desired, created by running the following. Because I'm not going to be using a static resolve, we're going to leave it be. SystemD resolved configuration. If methods incompatible with SystemD resolved to configure network interfaces, example PPP, etc., or use a local resolver or any other software that generates their own resolve.conf in etc. Disable the SystemD resolved to prevent any issues. Because we're not using a static resolved config, we're not going to touch that. Configuring the host name. So in this case, it's just going to be echo LFS LFS. So the host name will be LFS. Remove that. Remove. Oh, there we go. The LFS needs to be replaced with this given computer. Do not enter an FQDN. Information is hosts file. So LFS will be the host name. Customizing the hosts file. Decide on a FQDN, fully qualified domain name. If using static IP addresses, you also need to decide the addresses. Syntax for the hosts file is IP address myhost.example and any aliases for it. There's the IP ranges class A, B, or C. And we now need to create a hosts file. So in this case, I'm going to create this, and I already have a hosts file that I would like to use. So in this case, we get rid of everything except the loopback addresses. So in this scenario, what we want is this to be localhost.local domain, a local host, and then it's just FQD, and this is just LFS. Enter. That's the hosts made. Yes, it really is just that simple. No need to worry about it. It seems like it should be much harder. It's really not. UDIV information, sysfs, no device, no creation. This is just explaining how things are handled. Kernel module is not loaded automatically, and UDEV is not intended to load it. That basically explains that. So all of this is just going into detail about how the system will manage devices. Now we go on to the managing devices. As explained in the previous chapter, the order of which devices with the same function appear in dev is essentially random. USB camera or TV tuner sometimes sorry, will sometimes appear as /dev/video0. I can definitely 100% confirm that is true because they never have the same. Because I use a DSLR camera for various things, it will just show up as a dev video 0 or video 1 sometimes. For example, VLC sees TV tuner as an option, but sometimes it doesn't. So that's fine. And sometimes after reboot order changes, if you've only got one device plugged in, for example, my camera, it only shows up, well, there's always a video 0 there because of my video for Linux, so that is correct. It always shows something, but if I added something else, it would then show issues. For each of your devices, likely have this problem, even if the problem doesn't exist in your current Linux distribution, find the corresponding directory under sysclass or sysblock. For video devices, this may be sysclass video for Linux video X. Figure out the attributes that identify the device locally, usually vendor or ID, and then issue that. But I will do that for video for Linux. And then the rules that create the symlinks. So again, got no issue with doing that because it's a video thing that I might actually end up using myself. And this is just sorting out the SystemD time and date service. So for example, system time dated reads the etc adjust time, and depending on the contents of the file, sets the clock to either UTC or local time. So first things first, create the etc adj time with the following contents if your hardware clock is set to local time, which it is. And you can also use the time date CTL utility to tell the system to time dated. So there's no others. So to change your current time, do that. Change current time zone, do that. And you can list the available time zones. So what I will do is I will do time date CTL set time zone GMT. System's not been booted. That's because We're currently in a virtual environment, so it can't do that, which is fine. And starting with SystemD version 2.16, the synced daemon is enabled by default. If you want to disable it, do that. Because I don't want to, that's fine. And also note here, datactl does not work in a true root environment. It can only be used after the boot system is booted. Again, that was expected. Now it comes to configuring the, well, how text is displayed. So first things first, you can change key map value at any time by running localctl, but because we don't want to, you can also use localctl utility depending with the corresponding parameters to change the xlib and keyboard input. So all that, change key map, yada yada yada. Please note localctl command does not work in chroot, and that's fine because we can't touch it at the minute anyway. Configuring the locales, list of all locales supported by that. Now it's no bothers. Map that just explains how you get the information out, but because I'm going to be using ENGB, it's just ISO 88591-1 for the Western Europe English. If it's Eastern Europe English, then it's 8859-2. If I remember that correctly. So list all the supported locales, character maps, all of that, yada yada. So there's that. Warning, locales not supported. In several cases, xlib expects the character map to be listed. Once the proper locale settings have been determined, we can now create the locale.conf file. It's a good thing I already have all of this sorted out. So first things first, we want to copy this, paste this in. Now, in my case, it is just the language is LL. So it is ENGB 88 or dash 8859-1, and that'll be it. Just to make 100% sure, because I don't want modifiers or anything like that. There's that. And note you can modify the locale.conf with this localctl utility to use that, run that. You can also specify any other language, use that, but then again, localctl doesn't work in the true root environment because it requires the PID named number 1 to start. This file here is just a basic file that then expects a lot of the console interfaces to be ask for this file with input in it. Sorry, etc input rc. But well, we'll put that there as a standard because that's needed. The shells file. So this is just a list of the shells that are available because we're using a bash. That's what's there. It's just again a basic file, so no need to be concerned with that. Basic configuration, disabling screen clearing at boot time. The normal behavior for SystemD is to clear the screen at the end of the boot sequence if desired. This behavior may be changed by running the following. We will get this and put that in there because we want that. Disabling the temp file system of TMP. By default, temp is cleared, created as a temporary file system. If that is not desired, it can be overridden by executing the following command. That is not desired. Well, we'll keep that as a keep the tempfs for temp and keep that as is. Configuring automatic file creation and deletion. If default parameters are not desired, then file should be copied to there and then just edited as desired. So note that the syntax, so we're just going to leave that alone. Default services behavior. The parameters of a unit can be overridden by creating a directory and a configuration file in etc systemd system. For example, foobar.service. I like that name. It is rather funny, but we'll just leave that be. Boot sequence, it just shows you how to debug and all that sort of stuff. Working with core dumps. Core dumps are useful for useful to debug crash programs with a daemon, processes, just all of that, and long-running processes. That's fine. And that'll be it for the end of this video. In the next video, we will make the system bootable and then boot into it. So I'd like to thank you very much for watching. I have been Nick, you have been amazing, and I hope you have a wonderful rest of your day, and goodbye.